Hi kids, we will be going with this paper discussion. You can look at the first question. This question already came in some of your exams, so I am not going to explain much. I am attaching the question here and the particular solution of that particular exam, and on what basis we have done this, that also I have attached previously also, so now also I will be attaching. So the force will turn out to be simply sigma times of flux through that. Now flux through this and flux through this is going to be same, which depends only on the angle, q by 2 epsilon naught into 1 minus cos theta. So net force is going to be 0. In a Quincke interference tube experiment, a sound of fixed frequency from a loudspeaker is sent into two arms of the tube. One arm is movable so that the length can be changed, introducing an extra path difference. The sound waves recombine and are heard in a detector. Initially, the detector output is at maximum constructive interference. As the movable arm is displaced forward, first minimum occurs when it has moved by a distance 9.5. Then what is the speed of the sound? So those who have no idea about how the apparatus looks like, it is like this, and yeah, in case if you want to read, I will be attaching. Now this is movable. Now you should understand, okay, so if at all in the initial case, let me say this length and this length were equal for better understanding. So the wave going this way and this way will be traveling equal path, so path difference is going to be 0. Now if I push it by a distance x, now there will be x reduction in this arm and x reduction in this arm, so total reduction is going to be 2x. The other way of saying it is, if I push it by lambda by 4, then lambda by 4 length will reduce here, so this wave will be less in path when compared to this one by lambda by 2. So that is the idea. If you press it by distance x, then change in path is going to be 2x, and they said when it is going to be destructive, so when from constructive it should be a difference of lambda by 2. So extra path difference of lambda by 2 should be coming. From there you will be getting the lambda value, then you can get the velocity values. The only thing you should understand is, if you push it down by distance x, you are going to create an extra path difference of, you are going to create a path difference of 2x. The block is lying on a smooth surface with spring connected to it, pulled by an external force as shown. The velocity of the ends A and B are 4 and 2. If the energy in the spring is increasing at a rate 20 joules per second, what is the stretch in the spring? So that's a very straightforward question. Rate of change of potential energy in the spring, that is d by dt of half kx square. Differentiation of this is this much. Now what is the rate at which this extension is varying? That depends on what is the relative velocity. Relative velocity is 2. So with respect to this end is increasing at a rate 2. K value is given in the question. This was given in the question. You need to find what is x. 1 mole of monoatomic ideal gas is subjected to a thermodynamic cycle as shown in the temperature entropy diagram. The cycle consists of 3 processes containing states A, B, C. AB, a process where temperature increases linearly with entropy, AC, and isothermal compression. That you can see in the figure also. Then they were asking what is the ratio of heat rejected in isothermal process to work done and all. So anyway, let us go step by step. That's the basic definition in reversible process. So if I want to calculate Q for any process, then I have to integrate TdS. TdS is going to be area under the graph. So for this it is going to be 0. For this it is going to be positive. For this it is going to be negative, because S is reducing. Right, so positive and area under the graph you can calculate, negative area under the graph you can calculate. So for the cycle, net Q is going to be minus half T naught S naught. So for a cycle, change in internal energy will be 0. So work done is going to be again the same thing. Work done is going to be negative. But they were asking, you take this magnitude and you take this total work done, then you take the ratio. So it should be minus 4. They have given 4. I think maybe will you double answer if possible. A cubical block of side 30 centimeter having density 500 is floating. Now you should understand this density is half of the density of the water. When you write initial equilibrium situation, you will understand half volume is outside, as it is cube, half length is outside. Dimensions of the base of the container are 45 into 60. 45 into 60. This area will turn out to be 3 times of this base area. This base area will turn out to be 3 times of this base area. You can look into that. Find the minimum work external agent need to be doing so that the block just gets submerged. Now you should understand, if this area is A and this area is 3A, then this remaining area here, other than this area, remaining area is going to be 2a. So if you press it down by distance x, it is going to displace a volume of a into x. So the water coming up should be of volume a into x, but it will be coming only through an area 2a. Or I can say if this is x and this water level goes up by y, then the volume went down is extra volume coming here is a into x. That volume of water will be coming here, which is 2a into y. Or you can clearly see if this is a into x and this is going to be 2a into x by 2. So I have directly written this. Understand, if you press it down, water level is going to increase. Now in that case, extra buoyancy, extra volume submerged. Now this is going to go down by x and water level is going to go up by x by 2. So extra length submerged is going to be 3x by 2. So extra volume submerged is going to be this much. Extra volume submerged is this much. So this extra buoyancy, so you need to oppose that much extra buoyancy. So work done by you will be this much for a small distance. Then you have to integrate from where to where, when it is completely submerged. So when this is going down by distance some x naught, this water level will come up by distance x naught by 2, then totally it will be submerged. Or I can say x plus x naught by 2 should be equals to L by 2. So x naught is L by 3. So you have to push only by L by 3. If you push by L by 3, then L by 6 water will be coming up, then both will be at the same level, right? You just have to integrate and substitute the values. A trolley of mass 2 kg moves along concave bridge forming an arc of circle of radius 1 meter. A rope of length 50 cm is attached to the trolley, at the end of which a load of mass m is secured. At the moment when the trolley passed the lowest point of the bridge, the rope was positioned vertically and the velocities of the trolley and the load are equal to 3 and 4. At this moment, the normal force is N, with which the trolley presses the rails. The rope is weightless. Okay, so if you understand, the trolley is going to perform circular motion in ground frame with the speed 3. So if you draw the free body diagram of trolley, then there will be normal, mg and t. So normal minus mg minus t should be providing required centripetal. Normal minus mg minus t should be providing required centripetal mv square by r. So trolley's acceleration is this much. Now with respect to trolley, this is going to perform circular motion of radius L. So with respect to trolley, this velocity is 1 and radius is half. Now the real forces on this is tension and mg. But with respect to trolley only, it is going to perform circular motion of this much radius. So, but as trolley is accelerating, when you observe from this frame, you should include pseudo force. Trolley's acceleration is this way, so you should include pseudo force in this direction, which is going to be this mass into this magnitude of acceleration in this direction. This guy's acceleration is 3 square by 1 or 9. So pseudo force on this guy will be 9 into m in this direction. Real forces, pseudo force, circular motion in this frame. Then from there you will be getting t. If you substitute it back, you will be getting n. Understand, we know this motion in ground frame, we know what is this kind of motion in this frame. So we need to change the frames accordingly, according to the given information given information in the question. 1 mole of ideal monoatomic gas performs a process whose graph in Vt coordinates completely lies on a straight line. Find the heat capacity at point A, at which volume is V naught by 2, temperature is T naught by 2. So anyway, we have in all this thermodynamics, we have only energy conservation. We will write energy conservation. For any process, this is defined as NC dt. If it is constant pressure process, we use it called as CP, constant volume process CV. For this process at that particular location, we don't know, so they are asking you to find this number of moles were given. du is always NCV dt, work done is PdV, and ideal gas equation. These are always valid for this particular question. This is the line equation which we need to consider. This is happening only in this question. These two will be valid in any question. This is valid only in this question. So we need to use this information to find C. So how to find C? You can bring this dt here. So basically you need to find this thing. You need to find dV by dt. dV by dt from here is minus V naught by T naught, and you need to find the P also at this location. P at this location, you know temperature, volume, so you can find the temperature there. You can substitute it back. Then you will be getting what is the value, C value at that particular location. A coil with inductance L1 having N turns and area S per turn is placed in external uniform magnetic field with induction B0. The field lines are perpendicular to the plane. A second coil with inductance is located outside the field. The resistances of the coils and connecting wires are negligibly small. Initially there is no current in the coils. The external field is switched off over a time interval as shown in the figure. The charge that flows through coil L1, see, understand, the charge flowing through L1 and L2 will be same. Basically there is change in flux, or you can say there is time varying magnetic field, so there will be induced electric field which will be driving the current, which will act like EMF. We just take help of Faraday's law once we understand the reason is induced electric field. So there will be an induced EMF of this much. Flux change in one loop is because of change in magnetic field. This is flux change in one loop into number of loops with a negative sign which says opposite direction. Anyway, that doesn't really, it's not really important. So when you write the loop equation, EMF minus L1 di1 by dt minus L2 di2 by dt is 0. Then you need to find charge flown, that is I dt. Basically you need to find I, then you need to find I dt. So let us integrate and find I. Initially magnetic field was B0, later on it is reducing. Initially when the current is 0, magnetic field was B0, at any magnetic field B, current is I. From there you will be getting I. Then if you integrate with, if you multiply both sides with dt and integrate, you will be getting what is the charge flown. So here you will be getting B dt integral. B dt integral is nothing but area under this graph. So you should calculate what is the area under that graph. You can see a triangle, you can see a rectangle, you can see a triangle. You can calculate area under that graph, that will turn out to be this much, right? And L1 plus L2 from the question we can substitute. The only thing is writing loop equation, then integrating it 2 times. Two parallel electrically conducting long rails are placed in a magnetic field with induction oriented vertically downwards. Now yeah, it is like a wedge thing. When you are observing from the top, it looks like this. Okay, it's like a wedge thing and there is some kind of cylinder. The upper end of the rails are connected to resistor. Resistor they can't show here, so they have shown it here. A hollow cylinder of mass m and radius is placed at the end of the rails and released. The cylinder starts moving downwards with rolling motion, that is without slipping. During the motion, its axis remains perpendicular to the direction of the rails in the situation shown. The initial acceleration, understand, at the initial moment velocity was 0, angular velocity was 0, so there won't be motional EMF. See, it is magnetic field is not time varying, so there won't be induced electric field, there will be only motional EMF. But initial velocity is 0, so there is no motional EMF. So it looks like normal rolling question where you will be writing, maybe you can write torque equals to I alpha about the bottommost point and you can get this acceleration, which you would have done in the class. Pure rolling acceleration is going to be g sin theta by 1 plus beta form. Now I have a problem with the rest of the things, because if the current has to conduct, it has to conduct only through the bottom of the cylinder, So I am expecting the current to come like this and go through the resistor, but that is pure rolling, so it doesn't have any velocity, so there is no motional EMF in that strip of the rod, in that strip of the cylinder. So if there is no motional EMF in that strip of the cylinder, I couldn't see why current has to flow in resistor. Anyway, they have given some solution. If it makes sense to you, if people look into it, or if I see, like if I am making something wrong, I'll upload it in the next discussion. And probably I'll be attaching extra PDF with it, why we shouldn't trust Faraday's law blindly. We should always look at the reason. There are only 2 reasons, motional EMF or induced electric field. This will come under motional EMF and the previous one come under induced electric field. A source of sound and observer are located in space. The apparent frequency of sound received by observer varies with time as shown. You can see the apparent frequency has only 2 values. If the source is, let me take a simple case. If the source is here and observer is here and moving this way, you can see when the observer reaches here, you will be hearing the same frequency, here more frequency, here less frequency, and the frequency will keep on changing because the angle will be keeping on changing. So when the figure is like this, the meaning is the motion is along the same line. So once you understand the motion is along the same line, option D is going to be wrong. Remaining all may be true. If only source moving with a constant velocity along the line joining, if the source is moving in this direction alone, or if the observer is moving in this direction alone, or either both observer and source are moving with a constant velocity and their velocity is always along the line joining. So the only thing you should understand is they should be along the same line joining. So ABC can happen. Okay, so I will be attaching a PYQ also, where you will be seeing the graph doesn't look like this. Then it will make sense why we are talking about it should be lying along the same line in our question. A solid conducting sphere of radius r has a cavity or not. A point charge q is placed at the center of the cavity. The dipole moment p bar is placed outside the sphere as shown in the figure. Then they were talking about certain options, and we have already seen the first thing what. Okay, so basically in the question they were asking you to mark incorrect options. So the first thing you should be doing is using Gauss law. You should understand what is this charge, that is going to be minus q. Then as this is neutral, if this is minus q, this is going to be plus q. Because of this guy there may be uneven distribution, so we don't take much risk on guessing it. Then we need to start thinking in terms of pairs. Net field here is 0, field because of this pair is 0, field because of this pair is also 0. Then if we want to calculate potential at O, okay, so let me go with option by option. Force on Q due to the dipole, force on Q due to this pair is going to be 0. Force on Q due to this dipole alone is going to be, it's like field here into charge here, that is 2 kp by this total length cube. 2 kp by this total length cube into Q will be the force because of the dipole, which will be exactly cancelled by this guy. So option A is incorrect, which we are supposed to mark. Option B is correct, which we don't mark. Then option C and D are going to be incorrect, which we will be marking. We will see why they are incorrect. Potential at A. Potential at A directly is finding hard. So we will find potential at O. Field because of this and potential because of this will be 0 outside. That you would have understood already. So let me neglect him for some time. So potential field because of this pair is 0 everywhere inside. So potential because of this pair will be same everywhere inside, which is easy to calculate at O. At O, potential because of this is going to be kp cos theta by this distance square, which will give you this much. And due to this charge, that charge though it is uneven, it is at equal distance r. So potential due to that charge is this much. Potential due to this pair is 0. So potential at O is this much. Now if I want to calculate potential at A, again because of this pair it is going to be 0. Because of this we don't know, because we don't know its charge distribution, but because of this we know what is this value, right? But we know these two potentials should be same. So from there you will be getting what will be the potential because of the induced charge, that is this minus this. Anyway, they won't be coming out to be C and D, so that's fine. A thin soap film of thickness L and refractive index mu is present in vacuum, and parallel beam of light is of wavelength lambda is incident on one face of this film at an angle theta with the normal. The beam can partly reflect and partly refract every time it is incident on one of the two faces of the film in its subsequent journey to infinity. Let us consider one ray of this beam as shown. Ray 1, ray 2, ray 3 with the emergent rays into vacuum from the original surface. Then for theta equals to 0. So theta equals to 0, it is almost normal. So this is going to be T, this is going to be T almost. So they were talking about interference. Those who have no idea about interference, I will be attaching PDF from H.C. Verma. So you can read that in case if you are interested. Those who know, they should be able to make sense. They were talking about ray 1 and ray 4. Understand ray 1, it is undergoing reflection while going from rarer to denser, so there will be a phase change of pi here. Only for this one there will be a phase change of pi. For this one there won't be any phase change of pi, no phase change of pi, no phase change of pi, no phase change of pi. So only when we talk about ray 1, we will be talking about phase change of pi, which you should be able to see in A and C. In only option A and C they are talking about ray 1. So there only we will be talking about phase change of pi, which is equivalent to path difference of lambda by 2. So if I look at the first case, they were talking about between 1 and 4. 1 and 4. Now this path is similar. Other than this ray is traveling 1, 2, 3, 4, 5, 6, 6t, that is 6 times of mu t extra path length, optical path length. And this one is coming because of phase change of pi. Now that path difference should be equals to even lambda by 2 for constructive. When you modify it, you will be getting this one, which matches with option A. Similarly, for the second case, it is 2 and 3. 2 and 3, we don't talk about extra phase change. Between 2 and 3, the extra path difference is only 2 mu t. That should be equals to even lambda by 2, which doesn't match with option B. They were telling that should be equals to 79 lambda, but we concluded it should be even lambda. So similarly, in the third case, they were talking about 1 and 3. For 1, we will be considering that extra phase difference here, 1 and 3. So there will be 4 mu t and extra phase difference pi converted to path difference lambda by 2. That should be equals to odd lambda by 2, which turns out to be this much, which makes option C correct. You should understand, if this is 424, 424 by 8 will be equals to 53 lambda. So option C can happen. Then again, ray 2 and 4, there is no extra phase difference. Ray 2 and 4, that is traveling an extra path of 4 mu t. 4 mu t should be equals to, okay, so sorry, these two are destructive, so odd lambda by 2. These two are constructive, so even lambda by 2. Okay, and even lambda by 2 plus or minus lambda by 2 will be odd lambda by 2. Odd lambda by 2 plus or minus lambda by 2 will be even lambda by 2. All those things you will be knowing. A weightless inextensible thread thrown over a pulley is attached to a load of mass m located on a smooth horizontal surface. A boy pulls the horizontal end of the thread with a constant speed u. At some instant, the inclined section of the thread makes an angle alpha with the horizontal. The pulley is at a height h. H is constant, alpha is varying. So right now it is alpha, maybe alpha naught. Consider only motion of the block before it lifts off the surface. So it is going along this surface till wherever we are talking about. The middle point of the string between the block and the pulley. See, obviously when it is here, it will be some point, or like when it is here, this is the middle point. When it goes further, middle point is going to change. They were saying that middle point is going to change from moment to moment. Then they were asking certain values. You can see when you are pulling, this guy is moving, so this motion are related somehow. The easy way of doing it is take Pythagoras theorem. X square plus h square is L square. Then you can see h is fixed. If you when you pull this L is reducing. If this L is reducing, this L will be reducing. So you can differentiate it to understand what it is. If you differentiate it again, now they said u is fixed. So the rate at which this is changing is constant. So dl by dt is constant. L double dash is going to be 0. Now if I plug in the values, dl by dt, the rate at which this is reducing, this is increasing is minus u, or this is reducing at a rate u. This is also reducing. So when you substitute, you will be getting some relation. Then here also you will be substituting. Then we want to write everything in terms of known. So x is going, tan alpha is going to be h by x. From there you will be getting x value, and cos alpha is x by L. From there you will be substituting. Then v in terms of u, because u was given, so I will be trying to substitute v in terms of u. U secant alpha, then secant square minus 1 is tan square. You will be getting this thing, but if you want to substitute this back, because option B was given in terms of v, so u is v cos alpha. When you substitute, you will be getting something like this with sine cube, which doesn't match with option B. Then anyway, we understood option B is wrong. The magnitude of acceleration, u is fixed, h is fixed, alpha is going to increase. If alpha is increasing, tan will be increasing, so acceleration is increasing. Now if you want to find a tension, T cos alpha is mass times of acceleration. Acceleration value we understood. So when you substitute, anyway, that shows option B is wrong. Then P is moving horizontally with speed v by 2. You should understand, midpoint of this refers to L by 2. L by 2, or you can see similar triangles L by 2, H by 2, X by 2. If X is varying at a rate V, X by 2 will be varying at a rate V by 2. So option A will be correct. Normal acceleration in the sense acceleration perpendicular to velocity. Whenever we understood velocity is this way, acceleration is also this way because it is not moving this way. So there is only tangential acceleration, there is no normal acceleration. A closed container contained water of amount m0, and due to evaporation from the surface of the container, the temperature of the water decreases. If initial temperature of the water is T0 and rate of evaporation is mu kg per second, then you need to do some stuff here. So generally when it is varying from time to time, this is what we will be doing. We will be drawing the figure initially m0 and T0. At any time its mass is m, its temperature is T. Now if you are using your brain, you should use modulus. If you are not using your brain, you will simply go with m plus dm, T plus dt. Now I am using my brain, water mass is reducing, so m minus mod dm. Temperature is also reducing because energy is given for the dm to evaporate. Time will be increasing, so T plus mod dt. Now you should understand mathematically, if I remove the modulus, dt is a positive quantity, time is increasing, final minus initial is positive. So when I remove modulus, it looks like T plus dt. Mass is reducing, so dm is a negative quantity. Mass is reducing, dm is a negative quantity. When I remove modulus, I will get minus dm. M minus dm is going to be m plus dm. The same reason goes for here. So mathematically, whether it increases or decreases, we are going to represent using m plus dm only, T plus dt only. Anyway, dm by dt was given, so mass at any time if you integrate, you will be getting option C is correct. Now comes the issue. What they were doing is they were not bothered about this dm, which is here but evaporated. From here to here, that dm evaporated. So its temperature was T here. Now when it is evaporating, its temperature is becoming 100 minus T, then evaporating. Sorry, there is an error here. This is not T, this is 100 minus T. So that mass is reaching 100 degrees, then evaporating. This is what I was thinking. So then it is going to be dm into S into 100 minus T. Then from there, energy needed for evaporation is this much, which was given by the rest of the mass available, which was this much. So its mass is going, that temperature is going to reduce by dt. So energy given by whatever is available will be taken by whatever is going as evaporation thing. This should be 100 minus T. Then the integration doesn't look same because they didn't consider this factor. So integration doesn't look same. So our answer doesn't match with their answer because they were not considering that thing. And after a long time, evaporation stops. So if we go with the same given conditions, they were telling it is always going with an evaporation. If we are supposed to use our brain, like it will be in dynamic equilibrium with the vapor, then it stops. But they didn't say anything like use your brain kind of thing. So they said it is continuously evaporating. So there is an ambiguity over option D also. List 1 shows some mirrors or lens, okay, wavefront, possible shape of wavefront just after being incident on them. Choose the correct options. So planar wavefront, rays going parallelly will hit and come parallelly only, where P is being this side. Wavefront will be here, P will be here, which makes option 5 correct. Which makes option 5 correct, but not option 2. In option 2, wavefront passed P. Okay. So in the next case, planar wavefront, that is parallel rays are coming, they will be focusing at the focus. So wavefronts are going to be something like this with center this thing. So they will be crossing P. They will be crossing P. So option 3 is going to be correct. Then in the next case, if a point object is here, then image will be formed this side, or the diverging rays will be even more diverging. If a point object is here, image will be forming this side. So after reflection, the rays will be going this way. As when you extend them, they will be meeting here. So when the rays are going this way, when you extend them, they are meeting here. Then the wavefronts are going to be this, like this, with this as the center, which gives option 4 correct. See, if it is a mirror, then the wavefront has to be this side. Now again in this case, diverging rays will be even more diverging, but they will be going that side. So wavefront is going to be that side of P, which is going to give you option 1. N plus 2 plane polaroids are placed parallel to each other such that the angle between the path axis of two adjacent is same. I think the planes were same probably, okay, but they were making some angle, parallel planes. If the first and last polaroids have parallel axis, path axis, so first one and last one are parallel to each other. Now suppose n equals to 0, understand what will happen if n equals to 0. So unpolarized light will be coming and its intensity will become I naught by 2 and it will be polarized in this direction. It will be polarized in this direction. So it will go I naught by 2 into cos square 0. So it is going to go as I naught by 2. Now if there was n, if n is 1, then you need one more polaroid in between them making equal angle, that is going to be 90 degrees. So whatever light passing through this, it will become I naught by 2 and polarized in this direction. Now that is not going to pass through this, so the eventually passing thing is going to be 0. So in the same way, if you want to generalize it, if they gave 10, we don't do this thing, we'll be generalizing. So if we want to generalize, we'll be getting something like this. 180 degrees, when n was 1, 180 degrees was divided into 2 parts. If n is 2, 180 degrees will be divided into 3 parts. So if there are n polaroids in between, then it is going to be 180 by n plus 1 angle between consecutive ones. So after passing through the first polaroid axis, it will become polarized and intensity will become I naught by 2. Then it will be passing through the next one, which is making an angle this much. So intensity will become I naught by 2 into cos square. Then again passing through the next one, it will become cos square times of that much. Then passing through the next one, cos square times of that much. So total n plus 2 polaroids are there, but after passing through the first one, it will become I naught by 2, then it will be passing through n plus 1 polaroids. So intensity will become cos square into cos square into cos square, that is n plus 1 times. Then you substitute n equals to 0, 1, 2, 3, then you will be getting all the needed options. If you can't imagine generalized situation, at least you do for n equals to 0, 1, 2 separately. We shouldn't be losing the easy marks. PQRS are 4 blocks. T is a big block supporting all the smaller blocks as shown in the figure. Assume all pulleys to be ideal and small. So then they were asking accelerations. So one thing is, I know wedge will be moving or wedge can be moving. Just to understand what could be the possible direction, I hold this. If I hold it, then this is going to go this way with the acceleration g by 2. This is going to go this way with the acceleration g by 2. I can see effectively center of mass is moving this way. So if I leave it, this tendency will be this way. That's not needed for solving the question, but I assumed in ground term this is going to have acceleration a this way. So when I observe from this frame, there will be pseudo force on every object available here, and this is going to be in this is not going to accelerate. I just put the pseudo force, that force will be calculating what is the net force available on this. So this is going to be non-accelerating thing now in this frame. So pseudo forces will be there. Now if you look at this thing, there is mg, there is ma. So net force on this thing, you can easily understand, is going to be something like this, that equals to total mass times of acceleration. So this will be going with an acceleration small a. Similarly, if I want to write for this 2 mg, 2 ma, both are aiding each other, that equals to total mass times of acceleration. But you can see I already brought capital A, small a and capital B into picture. So I need to write one more equation. Either I can go back to ground frame and I can write net external force in the horizontal direction is 0, that is m1a1 plus m2 sigma ma should be 0, or total mass times of acceleration of center of mass should be 0, which is m1a1 plus m2a2 plus m3a3 should be 0. Or I can do it from this frame also. In this frame, the net force in this direction is totally 11 ma. Net force in this direction is 11 ma, that should be equals to total mass times of acceleration of center of mass in this frame, or m1a1 plus m2a2 plus m3a3. So when you do that in this direction, this acceleration is 0, this acceleration is 0, this acceleration is 0, this acceleration is minus ma, that acceleration is 2 mb. Right? Net force equals to mass times of total mass times of acceleration of center of mass, or m1a1 plus m2a2 plus m3a3. Now you got 3 relations, you just need to solve them. Just solve those equations. And what is A? A is the actual acceleration of the bigger block. And what is small a? Small a is the acceleration of this one with respect to t. And what is small b? Small b is acceleration of this one with respect to t. Then relative acceleration of P with respect to, yes, so you need to do A plus B magnitude wise. So basically understanding only these three equations is important, rest all is solving. A long cylindrical tank of cross section area S is filled with two immiscible liquids of density rho and 2 rho. It has two holes of cross section S by 10. S by 10 is not very small, but still when you look at the options you understand they will be going with the regular method. A light movable piston frictionless is kept, then you need to find what is the initial speed and maximum force. Force is going to be rho A V square, which you would have learnt somewhere in center of mass, variable mass. Anyway, you should be understanding you will be applying Bernoullis between this point and this point. So if you apply Bernoullis between this point and this point, this pressure is almost going to be P naught plus mg by A. That you should be understanding when you draw the free body diagram of the piston. It is moving slowly, so you can take almost equilibrium. So pressure term, if I take this as reference, height reference, pressure term here is this much, and rho g h plus its velocity is almost negligible if you consider, that's what they were expecting you to do. That energy will be coming out as pressure plus rho g h term plus half rho p square. From here we will be getting Vb square. After that, if you calculate rho S by 10, rho A by 10 into Vb square, that is going to be the force on the water or force by the water. Similarly, you will be applying Bernoullis between this point and this point. So you should be applying Bernoullis between this point and this point. They should be of the similar liquid things. Now pressure here is almost going to be pressure here plus rho gh, because this was not accelerating we considered. So pressure here is going to be almost pressure here plus rho gh. That's the pressure term. With respect to this height, 2 rho gh term will be coming, height term, pressure term, height term, and its velocity is almost negligible. That should be equals to pressure term here plus height term here plus half into density into V square. From here we will be calculating VA, then 2 rho into A by 10 into V square will give you what is the force, right? Thank you.